Hello, I'm Rob Hollow, Education Manager with CSIRO's Space and Astronomy Unit here in Sydney, Australia. Before I begin, I'd like to acknowledge the Wallamatigal people as the traditional owners of the land I'm speaking from today and pay my respects to their elders past and present. And I want to cover today why astronomy should be an integral part of the education of students in every country. Why bother teaching them astronomy? Well, it's got inspiring imagery, it's something that engages students, it tackles big questions, and it provides a rich contextual learning environment in which we can use astronomy as the hook to cover a wealth of different scientific concepts and cultural concepts. It's a fantastic area in which we can engage students in mathematics and ICT. It could be an area in which students have to solve problems, develop their scientific literacy, and this can be done either through individual or through group work activities. And it's something that these days is well resourced. So there's a wealth of material and activities out there that teachers can use with their students. So where should it fit in the curriculum? This is an ongoing area of research, but fortunately, we have a few really useful guides now that can help us with this. Firstly, the Big Ideas in Astronomy resource that's been developed through the IAU, and it really provides an excellent framework that anybody wishing to develop a curriculum or respond to curriculum inquiries can show what are the key things that we think should be covered, and then use this to consider where, at what level it might be appropriate within the curriculum. And so if you haven't come across this, please go and read it. It's a fantastic resource. And so we know that astronomy is currently taught in most science curricula around the world. Many countries have an integrated science subject up to during compulsory schooling. And then it also appears in the senior physics, earth, environmental science subjects at the matriculation or sort of elective level. And some countries have actually developed specific courses on astronomy, such as GCSE Astronomy in England and the Cosmology Distinction course that we ran here in Australia, in New South Wales for 15 years for talented students. But of course, these specific subjects will only ever reach a very small number of the overall student population. And so whilst they're great, I think efforts for maximum impact need to be addressed at the core curriculum. And unfortunately, a colleague of mine, Saeed Salampour, led this fantastic paper a few years ago now with a team from many countries, looking at curricula in OECD and in South Africa and China, and then did sort of textual analysis to draw out where and how it fits in. I guess some of the key findings, unsurprisingly, is that most curricula do include astronomy concepts. By and large, though, this is what we might call the basic or the traditional astronomy concepts: day, night, seasons, phases of the moon, and the like. Most of this was at the upper primary, perhaps junior secondary, so typically around grade 6 level. Fewer curricula actually address areas of what we might call modern astronomy, including things such as cosmology, but also things like techniques, data, modern observatories, and the like. Even fewer, unfortunately, include cultural or Indigenous perspectives, which is a real shame, as there's a great potential and value in incorporating these with students. In Australia, we have an Australian curriculum. It's developed nationally, but the implementation of it is responsible for each of the 6 states and 2 territories. All students in Australia would learn science up to year 10 level. The curriculum has integrated strands: science understanding, what most people typically think of as a curriculum, that is the specific bits of content that you might expect. And the 4 sub-strands there include earth and space sciences. But interestingly, we also have science as a human endeavour, which provides a fantastic opportunity to use astronomy as a context for how we do science, the people that do science, the challenges they face, and the like. We also have science inquiry skills. And again, astronomy can provide an example here through the data analysis, communication, writing papers and the like. We have general capabilities, literacy, numeracy, ICT and the like. And interestingly, we have cross-curriculum priorities that are applied across all subjects. And each of these has examples where we can introduce astronomy, such as Aboriginal Torres Strait Islander histories and cultures, sustainability, and in terms of science collaboration through our engagement with other countries across Asia. Here you can see the key content area from science understanding at foundation, year 1 level, year 3 and year 5. So not unexpectedly, day, night, solar system, eclipses, seasons, positions of the sun, earth and moon and the like. And then at year 10 level, we're looking at the theories of the universe, the scale of the universe, galaxies, stars, and the Big Bang. Within the curriculum, there are what we call elaborations, and these are merely examples that show how the specific points can then be applied across the different priorities and capabilities. So the first one here, we can see how you could use astronomy to address the Aboriginal Torres Strait Islander perspectives. The bottom one is interestingly from the humanities and social sciences. And if you drill down in that, there's mention of astronomy. So we talk about the history of astronomy, development of astronomy in the Renaissance and the like, with Galileo. And then, of course, beyond compulsory science education at the year 11 and 12 level, astronomy generally can fit in most readily in, say, physics, earth and environmental science. And then here in New South Wales, we have 2 subjects where how we do science. And interestingly, the extension science students do their own project for a year. And quite a few students have used astronomy data and observations as their examples there. So again, the astronomy is the context. It's not sort of explicit in the curriculum there. But we do have some, in New South Wales, in the physics syllabus or in the Australian curriculum, we do have a small amount of the physics syllabus explicitly talks about astronomy details, the Big Bang, Hubble and the like. However, the challenges we face primarily come down to, if you had to put one thing on it, is that the vast majority of teachers, including science teachers, have no formal training in astronomy or how to effectively teach it. Hence, not unrealistically, they do lack confidence. There are perceptual problems. Many teachers would think it lacks practical work, or that activities have to be nighttime based. You go out and look at the stars. And also the idea that it's not an experimental science in the way that what we traditionally teach in many science curricula about, scientific method and hypothesis and variables and experimentation. Astronomy being primarily to first order an observational science doesn't fit that mold. And also just the very flood of new discoveries can be off-putting to some people. They think it's too hard to keep up. The result is often astronomy is one of the areas of science that is poorly taught relative to other areas, often rushed or, not given due credit. So with all these in mind, pretty obvious that really a focus for us as an astronomy education community should be on effective teacher professional development, providing support for teachers and developing resources that they can readily use in the classroom, and then making them aware of them and where to find them. So as a community, we need to be supporting curriculum developers, providing feedback to those that are developing, engaging with our curriculum and assessment authorities and looking for opportunities for input and review. And finally, we should always keep stressing astronomy as an example for cross-curriculum content and skills, and as an excellent context with which we can introduce the fascinating science that we all know and love. So every student deserves an effective, engaging experience of astronomy as part of their formal education. So thank you very much.